Hey, was anyone not here yesterday and didn't get the video packet? Anyone else? Okay, so we're just going to be working through the review packet. We did number 1A together, and so we'll just continue through our worksheet here. Okay, so number 1A, we just went through area, and area has no square within our expression. We're just doing top minus bottom or right minus left. So just make sure that we don't do too much with this. I know we're so used to this method and Washer method that we may be tempted to want to square the entire expression, but with area, it's just top minus bottom dx or right minus left dy. Okay. The nice thing is that we've gathered all the information that we could possibly need. So if we're dealing with the same shaded region, we can just reuse a lot of information that we've already gathered, even if it is volume with this method or Washer method. So, okay, so let's look at part B. Next. Okay, find the volume of the solid generated when the enclosed region is revolved about the line x equals 1. So x equals 1, that's going to be to the left. It's a vertical line. So let's go ahead and try that. Shaded region. Okay, we're rotating around the axis, so it's either going to be disk method or Washer method. So which one will it be, disk or Washer? Washer, yeah. There's only one place that this can support this method, and where is that? Yeah, y equals 0. That's the only flat surface that we see, right? Any other place. And also, we're never rotating around a diagonal axis. So even though there's a quote unquote flat surface here, it's got to be flat vertically or horizontally. So there's no place, even if the axis touches, that we're ever going to get Washer method or this method unless it's right here on the x-axis.
Even then, wouldn't it be that the line isn't fully on the?
Let's see. Say it again.
Wouldn't that be like Washer method as well if it's on the axis? Because like wouldn't the line not fully be?
It does because here, after this rotates, this object is not going to have any hollowness or gap in it. Yeah. So I think, yeah. So if you see a flat surface, yes, there are some times when flat surfaces can produce a combination of Washer and disk, but we're not going to see that. So I think the blanket statement is if you see a flat surface and the axis on that flat surface, we're going to have, it'll be safe to assume it to be disk method. Okay, so we need to draw two radius. And the radius will have to be horizontal. Got to extend out from the axis of revolution. So we have one that extends to the furthest boundary. That'll be our big R. And then little r will extend from the axis to the closer of the two boundaries. Okay, so anytime we see a horizontal radius, we gotta do what? Yeah, we gotta rewrite our equation. But the nice thing is, we did the area using right minus left, so we can reuse all the information that we've already gathered here. Okay, let's build our two radius that we need. Okay, big R. Right minus left. What's the right endpoint of big radius sitting on? Right minus left. Minus, what's the left endpoint of big radius sitting on? Right minus left for small radius. What's the right endpoint of small radius sitting on? Yeah, sitting on the radical that's been rewritten as y squared plus 2. So y squared plus 2. That's the right endpoint. Minus 1. Yeah, left endpoint is sitting on the axis. Wash your method. D equals pi in front. What are our bounds going to be?
0.
0 to 1.303, right? We're stacking the circular rings from down here all the way up here. Right? It's rotating all the way around. It's going to be, all these are going to be kind of strange looking objects, but we never have to worry about what they look like. Just have to be able to have some idea how to gather our data. Okay, lowest y value is 0, highest y value is 1.303. Okay, big radius squared. Make sure that we're squaring our radius separately apart from each other, that we're not combining it and then squaring once. Again, we got to square them separately. The rest goes in your calculator, so go ahead and try that. I'm gonna put this as under y1. I'll call this y1 is 4 minus x, and then I'll call y2 being x squared plus 1. Right? It doesn't change to well, it does change to a decimal. Sorry, a fraction, but you don't have to since it looks messy. So either is fine. I had it rounded to 3 decimal places there with I attached to the end. Part C. I want to make sure that you guys knew that I also printed out copies of the keys. So if you want to grab the key so you can kind of, if you're working ahead, you can see where you are. Okay, part C, we have enclosed region is the base of a solid. So cross section of the solid taken perpendicular to the y-axis is an equilateral triangle. So we're told what shape we're building on top of this. So there's no rotation here. This is actually the flat surface that we're building these shapes on top of. Okay, and I'll keep reminding us that, you know, if your base or if your shaded region resembles a geometric shape, it doesn't matter. Okay, so never look at the shape of your shaded region. It has no bearing on the rest of the problem. All right, so the first thing we need to identify is which direction this is talking about. So perpendicular to the y-axis. Let's think about that for a moment there. Let's think about the y-axis first. Which orientation is that? Right, vertical, right? Now we want something that's perpendicular to the y-axis, so it's going to end up being what? Horizontal, okay? It seems obvious, but we really need to spend the time to think about those two words and how they're interacting with each other, because there's multiple ways to say vertical, there's multiple ways to say horizontal. We don't want to just look at perpendicular, okay, that's definitely vertical, or y-axis, that's definitely horizontal, or vice versa, right? So make sure you take both of those words into account before you decide which direction that's referring to. Okay? I'm sorry? Well, there's no rotation going on. This is a cross section from yesterday.
Okay,
Right, right. Yeah. And also, there's, if it's washer or disc, they always will tell you revolved around, right? There's always some kind of a rotation going on. Yeah. And we're building triangles on top of this space here. Okay, so we know it's going to be horizontal, so we're just going to extend from one end to the other end. So everything from part B can just be brought down, right? We're going to use all that setup still. Okay, for area, we call this the length of a rectangle. For disc and washer, we would call this the radius of a circle, but now this is the base of, in this case, the base of a triangle that we're building on top of. So we're not drawing it, but the idea is that triangle shapes will jut out of the page, creating this three-dimensional object. Okay, so we'll call this the base length. Right minus left. So what's the right endpoint of the base length sitting on? Minus, what's the left endpoint? Okay, any adjustment that we need to make here? Parentheses, yeah. Otherwise, the negative won't distribute through correctly. All right, let me clean that up a little bit, so just less things to plug in the calculator. All right, so I have my base length. I'm gonna insert this into my formula. My area formula for an equilateral triangle is √3/4 base squared. So we just insert the base into the formula that we're using. So √3/4 base squared. Okay, our bounds will be the same as from part B. and no pi involved since we're now not dealing with anything circle related. We're just going to insert this directly into our volume formula, and then the rest goes in our calculator. Okay, try that.
So usually you can find the area and the volume.
I'm sorry.
Usually you can find both the area and the volume is zero at the area formula.
Right. So yeah, let me talk about that. So we know, so let me talk about, yeah, so let me connect that because, area is part of the volume calculation. So remember how with part B, we have pi r squared for this washer method. So disk and washer method, we have area formula pi r squared built into the integral. So same idea here. We're stacking these circular disks from part B from one end to the other. So your area formula will show up within your integral notation. So because part B was pi r squared, that's the area of a circle. And here, the area of triangle is √3/4 base squared. And then we always start with area. And then because we're having to accumulate the area from one end to the other, this is found first before we give it that third dimension.
Find the formula for the area then.
Exactly right.
And on the quiz, will it be like a part, like part 1, part 2, part 3? It's
They're all going to be mixed. Yeah. We have to be able to identify whether it's area, this method, or wash method. I think, I mean, it'll be obvious in terms of, is it area or volume? Because the problem will say, okay, find the area, then you're just know it's going to either top minus bottom or right minus left. Now for volume, it'll tell you that it's finding volume, but then you got to decide, is it this method or washer method, or is it cross section? I mean, if you see the word rotation, it's got to be either disk or washer. If you see the word cross section, and if you see a different shape identified, like a square or a triangle or a semicircle, it's going to have to be a cross section. So hopefully, identifying between those 4 topics won't be hard. I think the most difficult part is identifying between disk and washer method. But if we know where that axis is in relation to the shaded region, we should be able to tell that apart. But other than that, hopefully, we're not going to have any trouble distinguishing between area and cross section. Okay, number 2, or page 2. I want you guys to try this on your own. I will be working through it the same time that you do. So, and you guys also have the key, and then I'll kind of talk through the big points, make sure that you guys are hitting everything. So, okay, go ahead and try. Number 2, hopefully we can get through A, B, and C. Oh, let's also make sure that we are very clear about when something is a vertical line or when something is a horizontal line. If something is y equals, it's always a horizontal line. If something is x equals, that's always gonna be a vertical line. So I see students in the past who would get those two mixed up, and that just throws off their entire problem. So make sure that you know when something is a vertical line and when something is a horizontal axis of revolution. Mhm.
Is on computer two, so is that because you gap,
Because why?
there's a gap between the gap and the x-axis.
There is no gap. Right, because the x-axis is not part of our shaded region. We want to look at the gap. Is there a gap between the dotted line and the shaded region? So the x-axis, sometimes, I mean, x-axis could play a role, but if it is not mentioned as one of the boundaries, then we don't care about the x-axis. The x-axis is there just to give you frame of reference that where the graph is in relation to the origin. You can graph the y equals 1 line and the natural log of 4 minus x line to find that point of intersection. I'm going to write the full order paired here since I only need the x value right now, but I may need that y value later on. So, well, it's just I guess y value is just 1, so that's not difficult to know.
Right, so I graphed it to her natural log of x. Use instance. find the intersection, or if you want to zoom in, one you can, do some blocks. Second trace intercept. Pick points on close to the intersection and it'll find that intersection. Okay. Yeah, they're valid. I don't want to. And those fours have to be exact. So let me show you how process works. So that's when you first curve and second curve, so you're not gonna find the intersection. First curve, let's say you want the blue one for the first curve, play that shows. Second curve, now you want to tell the calculator that second curve to the red curve. Yes, now it's gonna catch you just enter again, it'll find an intersection. So if you enter 3 times, it'll find an intersection. Thank you. Okay, any questions with part A?
Part B, that dotted line is nowhere near the flat surface of the shaded region, so it's got to be washer method. We have to build two radius. Radius are vertical, so we can use the equations that's given to us. No need to rewrite anything here. Top minus bottom for both big R and little r. The bounds will be the same as part A. And again, your bounds is only for your shaded region. Sometimes we feel like we want to involve the axis as part of the bounds, but remember your bounds is only for the shaded region. Don't look at where the axis is. It's not going to have any impact on your bounds for your integral. Okay, part C. Okay, perpendicular to the x-axis. We're talking about building these rectangles. This is a cross section of a solid. And which direction is that? X-axis is what? Horizontal. Perpendicular to it. Vertical. Let's build the base. Top minus bottom. Okay. What's the formula for area of a rectangle? Base times height. Now the base we found, but the height, they're always going to have to describe how the height is, is the height just a number? Is it, and they always have to give you information so you can build the height. So it says height is twice the base. So let's see what that means. So if height is twice the base, what does that mean? Height is equal to what? 2 times natural log of 4 minus x minus 1. So if I want to find the area, my area will just be this times 2 times natural log of 4 minus x. Right? So my area is just combining the base and height together. I'm just going to merge the two parentheses together and call it parentheses squared. Okay, we haven't done rectangles yet, but I want to make sure that we feel comfortable with building a rectangle. Okay, volume. No pi. This is rectangles here, so integral. Bounds will be the same. We're doing same shaded region, same orientation, so the bounds is going to be the same for A, B, and C, right?
I have a question.
Mhm.
Why for when you plug in like the base and height to the area, why is the height part squared?
Well, it's two. I'm multiplying these two together. So what happens when I multiply these two together? The parentheses
Oh, it's yeah. This
ends up being squared, right? So I didn't want to write it out twice, so I just wrote it squared. Okay, enter in your calculator. Okay, we have about 10 minutes. I think we can make some progress here. Your homework is just gonna be page 3. I think within the next 5-10 minutes, you should maybe be able to get through half of it. And then I'll just leave you less things to do for homework. You also have the key in front of you. So go ahead and try that. Use your calculator to find your intersections. Does anyone not have the solution key packet? Okay, so your homework is page 3. I'll send out a reminder this afternoon. I want to have some help sessions for any students who want to work towards recovery for their previous tests. So I'll send out a schedule, but basically it's going to be tomorrow during advisement, Friday before school, and Friday during advisement. If you can't make any of those times, then we can figure out time next week. But if you have, so if you need recovery, I typically try to give you the key so you can kind of look through it and ask any questions that will stuff, or you can schedule with me when you want to take the recovery test sometime next week or the week after. Okay, all right, go get your phone. Thank you. Thank you.
Should feel like,